How do insulators and conductors work in electrical power transmission? Imagine a world without reliable electricity. Power lines stretch across cities and countryside, carrying energy from power plants to homes and factories. But have you ever wondered how this complex system keeps everything safe and efficient? Today, we will explore how insulators and conductors work together to make that happen. Conductors are the materials that carry the electrical current. They are usually made of aluminum or copper because these metals let electricity flow easily with very little resistance. Aluminum is lighter and less expensive, making it popular for long-distance power lines. Copper, however, is even more conductive and often used in smaller or more critical connections. These metals are shaped into wires called conductors, which are the main pathways for electricity. When electricity leaves the power plant, it travels through these conductors over hundreds or thousands of miles. But high-voltage electricity can be dangerous. That's where insulators come into play. Insulators are made from materials like porcelain, toughened glass, rubber, or plastics. They are designed to resist the flow of electricity. Their job is to keep the high-voltage current from leaking out of the conductors and touching the towers or the ground. Insulators are mounted between the conductors and the supporting structures, like steel towers or poles. They act as a barrier, preventing current from escaping and causing short circuits or shocks. Overhead transmission lines are exposed to weather and dirt, which can affect insulators. If they get dirty or damaged, they might allow electricity to leak or cause a flashover, a sudden electrical discharge. This can lead to power outages or dangerous situations. That's why insulators are rated for high voltages and designed to withstand environmental stresses like rain, dust, and pollution. If the voltage exceeds their capacity, they can fail, so engineers carefully select insulators with the right voltage rating for each line. The process of transmitting power involves stepping up the voltage at the power station using transformers. Higher voltage means lower current for the same amount of power, which reduces energy lost as heat in the conductors. The high-voltage electricity then travels through the conductors over long distances. Insulators keep this high voltage contained, preventing discharges to the towers or the environment. In simple terms, conductors are the highways for electricity, allowing it to travel efficiently across great distances. Insulators act like protective shields, making sure that the high voltage stays where it should be and that everyone remains safe. Together, they form the backbone of electrical transmission systems, ensuring that power generated at power plants reaches homes, businesses, and industries smoothly and securely.